Hello, everyone, and welcome to the GeekNarrator podcast. I am back with another episode. Today, we are going to talk about serverless architecture. And to do that, I have Yan with me, who is a AWS Serverless Hero. He's an author, he is a consultant, and also runs courses on different topics like AWS, serverless, app development on AWS, and cloud. Thanks a lot, Yan. I'm really excited to have you here today. And
Thanks for having me.
yeah, absolutely. Let's start with a little bit of introduction about your background, what you're currently doing, and how you ended up with serverless.
Yeah, sure. I have been working as a professional developer for almost, coming up to 20 years now. Starting in banking, and I think about 2010 was when I first moved to a company doing everything in the cloud with AWS. Back then, AWS is a very different beast compared to what it is today.
Yeah.
Much smaller. And I've been working on AWS ever since. Everything I've done from that point onwards has always been pretty much always on AWS. I've built mobile games with more than a multi-million daily active users. I have worked in the sports streaming platforms with, again, we had, I think, over 2 million concurrent users at peak. I have done various different things in that time. And I've gone through starting with EC2 to using containers to pretty much entirely focusing on using serverless technologies the last couple of years. And I guess since about 2019, 2020, I've moved to entirely independent consulting work, working with my own clients around the world and helping them succeed with serverless, because to a lot of people, this is still very much a new paradigm. And a lot of them are still discovering what are the best practices and how to structure the application, how to migrate the existing application from on-premises, but a lot of times from containers or EC2 environments to serverless. Yeah, that's what I've been doing right now. I'm working as an independent consultant, working with clients and help them go faster for less by adopting serverless.
Awesome. Yeah, there are so many topics we could talk about, but today we are going to focus mainly on serverless architecture. What does it mean? As we usually do on the show, we want to start very basic. So, for our viewers who do not know what serverless means, what does it mean? What do we mean by serverless architecture?
Yeah, it means a lot of different things depending on who you ask. But I guess for me personally, serverless just means pretty much any technology where you don't have to manage the infrastructure under the hood. And when I talk about infrastructure, I don't mean cloud resources under EC2 servers or the configuration for scaling thresholds or load balancing, or thinking about the provision capacity planning and how many instances I need to run on each AZ or availability zone so that I have got redundancy and all of that. And ideally, I also want to only pay for the service based on my actual usage, which is really important when it comes to some of the best practices or emerging practices that has been developed alongside with people that are using serverless. The most important of which is the use of ephemeral environments, whereby you imagine instead of everyone sharing a dev environment, I can have an environment per feature branch, so that when I start on work on a feature, I can create a fresh environment where I know I'm not going to interfere with anybody else's work, and nor are they going to step on my toes when I need to make a change. When I run my tests, I know I'm not going to cause other people problems because I've got this isolated environment just for the feature that I'm working on. And when I'm done, I'm just going to delete the environment like it's never existed. And because these environments are pay per use, you only pay for them based on usage. So essentially, there's no extra cost for having 100 of these services over having 100 of these environments versus just one environment. Of course, you still have to be conscious of the resource limits, the number of Lambda functions you can have in a region, number of API gateway APIs you can have, and things like that. But by and large, you can just have as many of these environments, temporary or ephemeral environments, as you need. And it really makes the development a lot easier, especially in the environment where lots of concurrent work is happening and the developers are having a hard time not getting into each other's ways. So those are some of the characteristics I like to think about in terms of having automatic scaling, not having to worry about managing and securing the infrastructure. EC2 instances, that's very important because that is a whole class of security problems that I don't have to worry about. There's an entire class of attack vectors that I no longer have to worry about in terms of securing my operating system and the machines. I can tell you that for a very long time when I was working with EC2, the moment my EC2 instances comes up online, I'm going to be seeing login attempts from random IP addresses because attackers are phishing. They're trying to get into your EC2 instances. And especially nowadays with crypto mining being still a thing, there's also a lot of crypto jacking attempts. People trying to get into your account so that they can bring up EC2 instances to do crypto mining. and things like that, which I just don't have to worry about when I'm using technologies like AWS Lambda, or when I'm using databases that I don't have to worry about how many nodes I need to run, what's the CPU allocations I need to put on those machines, when I'm using DynamoDB or using S3 for storage. So there's lots of services that I would classify as serverless, even if they're not necessarily compute. So if you think about the function as a service, you've got Lambda functions, you've got other similar type of things, but then the serverless is not just about function as a service. There's a lot of managed services that can be classified as serverless based on those few criteria that I've outlined, including being able to pay by usage.
Yeah, that makes sense. And that describes or covers a lot of areas that I
Yep.
want to talk about. I just want to dig a little deeper on the problem that it solves. So you mentioned it's easy to set up. Developers do not need to worry about the infrastructure and the security and the issues around that. And as you mentioned, gave an example on EC2 that there's a lot of bad actors trying to hack something and log into your machines and all that. So you don't have to worry about the infrastructure, and you can focus only on the business logic that you want to write.
Yep.
And then there would be like cost aspect to it because you only pay for what you use. But given all these dimensions, like why was serverless a thing? Like what was the core problem it was trying to solve? Was it cost? Was it easy setup? Or was it letting the developers only focus on business logic and nothing else?
It depends. All of those things are reasons for why you want to go to serverless. And of course, depending on who you talk to, those things mean different. Those things have different importance to different people.
Yeah.
So for, say, a small startup, for instance, being able to move fast means that you can execute your idea a lot faster and be able to iterate your ideas against the market quicker, which means that you have a competitive advantage, right? That could be so the fact that you can have fewer developers getting the same amount of work done and being able to iterate faster on your business ideas while not having to pay a huge amount of upfront cost for setting up infrastructure. All of that is a huge advantage when it comes to startups. But if you talk to, say, like a huge enterprise, compliance and security are probably top of the agenda for a lot of those enterprises. And I've spoken with a lot of big banks, and the reason why they go to serverless, quite oftentimes you hear security as to the top reason, because having AWS take care of all this infrastructure related to security and being able to not have to worry about people logging onto the machines that's running your code, and a lot of the other security aspects you get with Lambda and things like that, where you can have really fine-grained access control for individual functions that execute some business logic, means that you have a lot tighter control around security. And not to mention all the other stuff I mentioned earlier in terms of the security of the operating system itself, the networking, as if using containers, also worry about the security of the images that you build your container images on top of. So that's the entire supply chain that you have to worry about. Security becomes a big reason for enterprises to go to serverless, but also because, again, that productivity, the ability to compete with other competitors who are able to execute a lot faster. The time to market is always a big reason. And personally, for me, it's the big attraction for serverless, the fact that I've spent the 10, 12 years of my career just doing the same thing over and over that doesn't add value to the customers ultimately. The amount of time I spend in terms of managing or babysitting the infrastructure versus actually writing the code that my customer actually wants, which could be something as simple as adding a homepage to log in or whatever, versus, setting up machine images, making sure that every couple of months I rotate or update all the stuff on the EC2 instance, create a new machine image and reviewing the scaling thresholds, all this other stuff. I was easily looking at a 70-30 split, where 70% goes to managing and babysitting the infrastructure and 30% doing the stuff that actually brings actual value to my customers or customers for my business that I was working for. It means a lot of my productivity and a lot of my time is just wasted on doing things that doesn't actually add value to the business directly. And being able to offload a lot of that work now to the cloud and let the cloud do the heavy lifting means that the more of my time is now able to be used to solve actual business problems or problems that the customers is experiencing, so that the business can add value to its customers. So that is a huge draw for me. It means that I'll give you an example, a while back at the help a client launch a new social network. We had a really tight deadline. I was a one-man backend team. I was setting up the entire AWS environment with multiple AWS accounts and trying to do security best practices, using AWS organizations to organize all the different accounts, setting up the governance rules, the guardrails, and all this other stuff on top of building a entire backend for the mobile app, and then a separate backend for a CMS system. And we have to launch on time and make sure that the system can scale, because the first version of the app running on 2 PHP servers crashed and burned. And the client had went to the investors, got another round of funding to do this version 2, and they can't afford to mess it up again. So I was able to do this whole thing on my own, on the back end, at least in just 4 weeks. It's the kind of thing that would have taken an entire team to do, if you want to do it properly. And the system went live. We had no problems, literally 0 issues after it went live, and the client was super happy. And all in all, I think we're paying something like $60 a month. And most of that was going towards having a cache node so that we can improve the performance and the response time, all that. So the customer was really happy. And ultimately, that means we were able to solve a business problem very quickly with very few resources, and have a system that is both scalable, resilient, secure, and cost efficient. So all of those are really good reasons for why you want to go to serverless. And of course, depending on who we ask, those things have different values or different weighting to different stakeholders.
Yeah, that makes sense. So let's say I'm talking about a single developer or a startup or an enterprise. So these would be using serverless, and their reason for using serverless would be different, because as a developer, I just want to quickly get started and work on my idea and create something very quickly. So that might be my reason. For a startup, let's say lack of experience on infrastructure management, operational things might be a reason or might be a motivation to use serverless. For enterprise, security can be one of the reasons for using serverless. So that sounds great. And we know what kind of problems serverless can solve. I want to understand how this works, right? So as a developer, let's say I write a Java application and I want to deploy it somewhere on serverless, let's say. How does it work? Like, how does it get deployed? Or I have to think differently and write my code differently in order to able to use the serverless architecture.
I would say ideally you want to think about how you build applications differently. Because there you mentioned, the first thing you said was, I've got this Java application, how to deploy it onto serverless. Why start with Java application? Why do you have to write all the code? There are services I can use that solve a big part of your problem. Because writing code is not, it means to an end, it's not the end. As a business owner or entrepreneur, I don't care about your code. I care about having a product that does whatever the customer wants to do. And if you as an engineer, you propose, let's use this service that does 90% of what we can do. And then I write a bit of code to make that last 10%, to customize it, to do whatever, then that's probably a better solution for the business, because I have less ownership on code that I need someone to help me write, help me maintain, help me support it and fix it and whatnot, whereas a service can get me started right away. Now, as an enterprise, that may not be the same, because as an enterprise, I have to go to procurement to get this survey signed off, and that might be a 6-month endeavor. And maybe I need to get them through some security bids and all this other stuff. And maybe I'm in a regulated environment, so there's also other compliance frameworks I got to think about. Again, the context is going to be different. But if you're thinking about, okay, a small shop with 1 or few developers, there the question is, okay, I've got a problem I need to solve. I need to provide some business capabilities. What's the best way to provide that? Is writing code the right solution? Not always. In fact, it's probably the least favorite solution, because code is a liability. If I write that code, I ship it into production, it means, okay, I'm on the hook to support for it. Something goes wrong, you better hope that I can wake up in the middle of the night and figure out what a problem is, versus having it be someone's responsibility to fix it. So again, we have to think about how we build applications slightly differently. And this is where we oftentimes hear people from the serverless world talk about serviceful, because at the end of the day, we want to use services that can provide the value as much as possible. And that often means that, okay, instead of writing, say, a Java application that's going to do some clever storage thing, can I just use S3 for that? Instead of hosting and running Kafka on EC2, can I use the managed service? Can I use any of the services that AWS offers? SNS, SQS, EventBridge, Kinesis. There's a whole host of different messaging services that I can get out of the box with AWS. And if those services are good enough for my requirements, in that case, what are the code that I absolutely have to write to implement the business logic that only my application and my business can provide to my customers? And I can use everything else that AWS offers, or other, whatever service providers or cloud provider offers, And so that I can build this application
Mm.
on top of all of those building blocks that I can get from a cloud provider. So straight away, you're not really thinking about how can I take my code and deploy it somewhere and run it there. You think about how can I solve this business problem using as much as possible managed capabilities I can get from the cloud provider so that I can extract the maximum amount of value from the cloud so that I can get the best value for my investment in terms of both time, but also in terms of my operational cost of what I pay the cloud provider to use these services.
Yeah, that makes sense. And so that brings us to the way of thinking while we are architecting our applications. More think about, okay, I have to create this application and then deploy it somewhere, but you have to think about in terms of what problems you want to solve and what
Yeah.
solution already exists. So you want to write as less code as possible, because
Yes.
I like that quote. Code is liability. Which is
Yes.
pretty true, because once you write a code, you have to maintain it, and that's where the most of the cost and effort goes. So I pretty much like it.
Good.
So let's try to understand, like, how does it compare? So let's say if I'm using a service like S3,
Yep.
am I like thinking serverless, or what is the difference between the serverless and using a managed service like S3? Is it the same? Is it different? How does it compare?
Based on the criteria that I defined at the start in terms of what is serverless, S3 is very much a serverless technology, a serverless storage system.
Yeah.
But your application, unless you're providing a storage service that you're just putting on top of using S3 as your back, and then you're giving your users like a nice mobile app to upload stuff, then you probably still need to have a bit more than just S3.
Yeah.
So you may need to have an API that can accept, that can, do some service rendering or do authentication or do something beyond just, hey, here's a storage service that can use you can use upload your content and restore it for you, and you can retrieve it later. So your as individual service doesn't make an application if you like, but combining different services together, the different capabilities you get from, say, S3 with, say, DynamoDB, with, say, API Gateway and Lambda, you can start to put together a serverless architecture, an application that is going to provide some business value to your customers. In terms of how that compared to, I guess, more traditional ways of developing applications, where there's a lot more focus on, oh, let's write a Java application and we're going to run it on the bunch of EC2 instances, and maybe we'll still use S3. But then we're implementing a lot more things in our own code. If you take, I guess, a REST API could be a good example. So in the way our approach with serverless would be, okay, I've got API Gateway, which gives me all the routes and stuff. I can use Mito to do user authentication. And for individual endpoints and the paths, I've got one Lambda function per endpoint and per method. So I've got the functions that can, say, create a new user, that can, let's see, send a post or post a tweet. I have another function that, deletes a post or deletes a tweet, versus one monolithic Express.js app or Java application that does everything. We got internal routing logic, we got authentication, all implemented inside the Java application as middlewares. I've got caching, all of that, all implemented as part of the same Java application. Whereas if I was to do this in the serverless way, I will delegate a lot of the API, path routing, authentication, request validation, hashing, and maybe other things delegated to services like API Gateway, which can do most of these things for me. And again, I'm minimizing the amount of code that I have to own and support and maintain over time, because the code that I do write are the bits that my customer actually cares about. They don't really care about how I implemented this fancy authentication mechanism. In fact, if I implemented that myself, I've probably added 6 months to the project timeline rather than just spend 5 minutes and try to configure API Gateway to use Cognito. So straight away, you're going back to thinking about what are the business requirements, what are the problems we're trying to solve, how can I use a service to solve those problems so that I don't have to write a whole bunch of custom code just to do it.
Yeah, that makes sense. And that actually lets a developer focus more on the problem they are trying to solve rather than everything around it.
Yep.
And so what I've seen in my experience, that the business logic of this size, let's say, but surrounding that, there's so much complexity, and you want to support
Yes.
that, you want to support this. And all the bugs or the incidents or problems that we face is pretty much around that, like the security concerns or the rate limiting or load balancing or setting up some policies or servers going down, and all those are the primary sources of the incidents or bugs that we
Mhm.
face. And removing all that noise is pretty cool. The other thing when I think about serverless is the kind of vendor lock-in that I get, right? Let's say a lot of people talk about vendor lock-in. Is it really a problem? So what are your thoughts on vendor lock-in when it comes to specifically to serverless as compared to the traditional way of developing apps?
Sure. Vendor lock-in is, to me, is a very lazy way to just say, I don't want to learn something. Because I think it is. I've spoken with a lot of people, and most of the time, people don't really understand. People use the vendor lock-in as an easy argument to say, we don't want to try this. We've never tried this before, but we're not going to try it because vendor lock-in is because of what if AWS starts to hike the prices, even though none of the evidence over the last 15 years has suggested that AWS just or any cloud provider is going to just suddenly hike prices 2x, 10x, because we are still in a competitive environment. They do that, or the customer is going to go somewhere else. And also, the evidence actually points the other way, that in the last 10, 15 years, the prices has consistently go down for the different services you use as opposed to go up. And also, when you talk about the lock-in, it's never really a lock-in. It's a cost of moving that, of course, exists with every decision you've made.
Yeah.
From the fact that you use Java, I've seen companies spend years moving from Java to something else.
Yeah.
What about vendor lock-in when they talk about whoever that decided to use Java? As to whatever framework you want to use. If you use Java, what's the popular web framework you use? Whatever you use, okay, that is a lock-in. If you want to move away from that framework, that is months and months, maybe years of work. I've seen companies struggle to get out of outdated, no longer supported web framework written so tightly to the way that framework works that to move away from it would be many months or again, potentially years worth of work. And what about the fact that using databases, say, MySQL or SQL Server, again, that is a tie into a specific set of technologies. So every decision we've made up to that point, to including where do we ship our code and run them, that is a decision that has a moving cost. But none of them are locked in per se that you can't move. There would be a cost to change them. But at the same time, you've got to think about, okay, if we optimize for ultimate portability, what do we then also risk at the same time? We risk putting a lot of upfront abstractions. Again, back to some of the early days, a lot of people talk about capital expenditure versus operational expenditure. I remember Werner Vogel talks about this back in 2010 or 11 in a re:Invent talks where, why go to cloud? Because you can you can replace the capital expenditure of buying, 500 servers where you don't know what's going to happen in the future versus just pay for them as the way you need them. Same thing here. If you decide to optimize and guard against a potential need to move from one cloud to another in the future, you end up creating a lot of custom abstraction layers that you will have to maintain over time. That is more likely to create friction for your developers day to day. Those are costs that you're going to incur both at the start as a capital expenditure, a form of capital expenditure, but also as the burden to your development velocity over time. And chances are you're never going to move easily because you may realize that actually your code, like your Lambda functions, those are the easy parts. Those things you can easily rewrite or, spend a couple of weeks to just write it from scratch, because if you're doing microservices, you have small pieces of services that you can move in one at a time. And if you're following any sort of reasonable modern practices for building microservices, you should be able to move those services individually without breaking the whole system. And if those services are of reasonable size, you should be able to just move them, just rewrite the whole thing within a few weeks, right? So velocity is your best guard against the vendor lock-in. And how do you get the most velocity? By using services and having fewer custom written code that you have to maintain over time. And the other aspect of vendor lock-in people don't often talk about is that lock-ins also exist with other things as well. For example, you are dependent on specific technologies like Docker. That is also a vendor lock-in. What about the fact that Docker may not exist in 10 years' time? There may be a new format that you have to move to. Or if you're using Kubernetes, what if Kubernetes is no longer the hot and sexy thing that everyone jumps onto, is replaced by something else? Now you can't hire anyone that's going to come and maintain your Kubernetes cluster. So those are also, again, not lock-ins. They are coupling to decisions that you're making that has got a cost to move. So it's not fair. It's silly to just think vendor lock-in and just throw it around as if every other decision you've made has got no moving cost. And I think ultimately, a lot of time, what we're really seeing is that people don't want to learn a different technology because it challenges partly who you are, because we identify ourselves as a Java developer, a containers expert, and having to learn something different is a challenge to both our identity, but also is effort. We got a job to do, 9 to 5 at least. So now you're telling me I have to learn some other new thing. No thanks. And that's, I think, oftentimes ultimately what people are feeling. And when they push back on, okay, why serverless? What is this rubbish thing that you're trying to push me to do? Not necessarily vendor lock-in, but vendor lock-in is an easy soundbite that you can just throw out. But it's a silly argument. And of all the things that is going to create a problem for you when it comes to moving is data. Data has gravity. Unlike everything else, the data is actually difficult to move. When you've got lots and lots of data, the technology you use to store that data has got specific things you've got to worry about, but also data at large volumes, especially everyone talks about big data. Most people don't really have them, but the ones that do have the big data, trying to move terabytes and terabytes of data is not easy. I remember years ago, maybe not years ago, but a couple of years, maybe it's years ago, I think it was Facebook, they were doing some data migration and they're talking about several, I think thousands of petabytes or maybe hundreds of petabytes of data. And they found the quickest way, not the cheapest, the quickest way to do that was to load those data into big disks. I think Amazon has got this snowmobile thing that you can actually rent nowadays, which is a big truck that you can load your data onto. They would drive the data to your new data center and then load it that way. And that is actually the cheapest and fastest way to actually move large amounts of data because data has gravity. And the data is actually very difficult to deal with and really difficult to move. And doesn't matter what you do with all your abstraction layers around your actual code. If you're not thinking about how you can move data, you have a much bigger problem to worry about later.
Absolutely. I'm so glad I asked you this question because it changed the way I look at the vendor lock-in whenever people talk about vendor lock-in. So it's not really lock-in, it's just the effort you want to invest in.
Yes.
Away from something that you're using. And it exists at different level, as you mentioned. Like
Absolutely.
If you're using Java, there is certain kind of coupling. Another great point you mentioned was you can think about it as coupling rather than lock-in. You always have the choice to move. It's just that there will be higher cost depending on what you want to move. As
exactly.
Also given example of data movement. If you're not thinking about moving your data from, let's say, you're storing petabytes of data in S3 and how you want to move that data from, let's say, S3 to, let's say, GCS or something.
Even to DynamoDB or just moving data from DynamoDB to RDS or vice versa. Those lateral movements within the same cloud provider, those are equally difficult. Even sometimes move from, say, one database solution to another, even if they're self-hosted, you're still going to have the same problem.
That makes a lot of sense. Another interesting point people talk about while architecting applications is that using multi-cloud, like whatever service the cloud provider provides best in the market, they try to use it and create like an architecture having multiple cloud. So does serverless also work in that way? Is it possible to integrate, let's say, using one serverless, let's say DynamoDB, and then interact with some other serverless from cloud provider that exists? So is it also possible that this is the way we architect applications? What do you suggest?
I think multi-cloud is probably a lot of people's answer to vendor lock-in, but it's also a terrible strategy. And I think Corey Quinn actually wrote about this, it being the worst practice as opposed to the best practice a while back. If you search for Corey Quinn's blog, I think you may find it. Ultimately, actually one thing I forgot to also mention as well, that if you're going down this route to prevent a vendor lock-in, you're also blocking yourself from being able to extract and enjoy 90% of the value that you're actually going to get from the cloud provider that you've decided to partner with in the first place, because it forces you to use the least common denominator across all the different cloud providers. Sure, all of them offer some kind of storage service, all of them offer some kind of a functional service capabilities, but they all work slightly differently, from the basic security model to deployment model to just how they work in terms of the function signature for Lambda is slightly different, but that is the least of your worries. So if you want to make it work across multiple clouds, there's also data. Where do you put data so that you synchronize across all the different cloud providers? Means the only way to really reliably make that work is if you host the data solution yourself and try to make it work across multiple clouds. And I guess, again, it goes back to why do you want to do that? If your answer is, well, prevent vendor lock-in, then let's go back to that answer, that previous question and why that's a bad idea. But if your answer is, say, we are Slack, we need to have uptime, because when AWS goes down, people are going to rely on us to provide a reliable and stable communication channel to even talk to each other, find out what's going on with AWS. Then that may be a good solution to say, okay, you know what? We don't have a terribly complicated application, but what we need is ability to be more resilient than, say, when AWS goes down or particular region AWS goes down, then we have still up. Then maybe we can, and we're not really using all of these different services that AWS offers, and we have enough technical know-how and funding to high expertise to build this multi-cloud strategy. Then okay, fine, I'll bite. That's probably a good answer. But at the same time, if your worry just is only about the resilience, then AWS never really go down as a whole. Individual availability zones go down or have problems. Individual services have problems. Individual regions has problems. But as you go up and up the abstraction layer, you can always build redundancies across multiple instances, multiple availability zones, multiple regions for a lot of your application. Maybe not everything. There's a few services that are single region, which is going to be where your pain point is if you want to be truly multi-region. But multi-cloud also creates a huge problem when it comes to the organization level in terms of, okay, now you have to have relationships with 3 different cloud providers with which you have a much weaker relationship with each one of them. But also, how are you going to hire people that knows how to operate across 3 different providers? Yeah. Learning one cloud is difficult enough, and hiring people with the right expertise for one cloud is hard enough and expensive enough. Now you're going to do it for 3. And how are you going to architect your application so that you end up with what you end up with is I have more resilience than what one cloud provider can offer me. What most of the time, what is you have resilience, which is lowest of the 3. So you've got the same sort of, say, application critical path going through all 3 cloud providers. So any one of them have an outage, you have an outage. Yeah. So that's what a lot of people end up with, as opposed to what you want, which is if one cloud provider goes down, then okay, we are still fine. The other ones are still working. But again, if it's resilience that you want, then there are patterns that allow you to achieve higher level of resilience by just going multi-region.
Yeah, that sounds good. So again, multi-cloud out of the window, most probably, because there are better ways of doing it. And knowing all these patterns and the possibilities of, even if you want, let's say, resilience in your application, there are different possibilities you can add more resilience. And it can give you like an illusion if you're using multi-cloud, maybe I'm more resilient, my applications are more resilient. But in practice, it might be the same. It's just adding more complexity to your application.
I think in practice, you'll be worse than if you just invest into one cloud provider and really understand how it works, and then build more resilient applications with one cloud provider by going multi-region. Talking about illusion, I used to work in banking, right? We used to have all these redundancies. Once a year, they would send me to a data center where we have the entire backup for all of our applications. And we take turns to go to the data center to make sure that our applications still work. And I was sent to this data center a few times. You know what? Not a single time has it worked. You still tick the box, and we've got a backup, we're still compliant, but our application is not going to work because no one ever tries to run it apart from this one time a year. We find new problems every year why it doesn't work. And the application is not just going to stay still, it's going to evolve over time. It's a product, it's not just a piece of code that doesn't change. So every year there's a new problem that we have to figure out, okay, why is it not working this year? But of course, no one really cares because it's a box ticking exercise. But if your application actually depends on having more redundancy, you have a much better chance of succeeding by investing into one cloud provider and really understanding how it works and going multi-region than trying to go multi-cloud.
Yeah, that makes sense. With this, I want to move to the other point where we talked about what is serverless, right? So pay-as-you-go model or the usage-based model, right? I assume that these like cloud providers do not run your code if it's not required, right? So this brings to the problem of ColdStart when it comes to serverless. So is it really a problem, and when is it a problem? What kind of applications would suffer a lot from ColdStart as compared to some other applications?
Yeah, it is a problem, but again, it depends on the context. So for example, if I'm building something that is doing event-driven architecture where, okay, I'm going to see some ColdStarts, but if a user is not actually actively waiting for a response, then it can take 5 seconds, 10 seconds to ColdStart, so that it doesn't happen consistently all the time, and which in most production applications, it doesn't, then it's not a problem. And also ColdStarts happens, I guess maybe to explain it a little better for people who haven't really quite used the things like Lambda, with a lot of these services, so Lambda function, for instance, when a request comes in to say, I want to invoke your function to do something, the service layer, so Lambda has got like a front end, if you like, services that checks, okay, here's a request to invoke Yan's hello world function. Is there an instance of this function, that a micro VM, they use Firecracker under the hood, which is the Amazon's so open source virtualization layer, that has got Yan's hello world function running already? And if there is one, is it busy doing some other request? Has someone already using to do something? If there is, then okay, that's the free instance. I'm going to reuse that. Now, the request is pretty quick, it's pretty fast. But what happens if, okay, I've got 3 instances of this function running, all 3 are busy doing something else already. So now, as the front-end code that received this invocation request for this hello world function, I have to then create a new worker. I have to first identify from the cluster of EC2 bare metal instances that I can use. I can find one that belongs to Yan's account, because with Lambda, they don't actually do multi-tenancy on the instance level. So they will only run your functions on the same instance, so that you never get a case where different customers' code are running on the same EC2 instance, even though you may have different functions running on the same EC2 instance, but that's separate. So I found an instance I can allocate your code very much similar to what you expect in the kind of Kubernetes allocation pods and all of that stuff. You have to create a new worker execution environment. And as part of that, if you're using Node, that means you have to initialize the Node process and all of that other stuff. So all that takes additional time before I can say, okay, the Node environment is ready. We've initialized your module, and now I can invoke your designated handler function on your module, and then you can actually run your Lambda function. So the first request that triggered the creation of a new execution environment and node environment and the initializing your dependencies and modules, that is what we call a ColdStart. And if you have a really fairly stable traffic, like a normal bell curve, then and most production applications do, means then you're not actually going to see a high percentage of user requests being handled by a ColdStart. And where it does happen, you can add, depending on the language runtime, depending on the size of the application, how much dependencies you're bringing in, number of different vectors, you may see a few hundred milliseconds being the actual overhead of a ColdStart, or it could be a few seconds or even tens of seconds if you're using like Scala, which has got additional overhead on top of Java and the JVM and the class loader and all this other stuff. So I've actually seen the Scala functions, ColdStart takes, 10 seconds or more. So depending on a number of different factors, they can add quite a bit of time. Now, the difference is, okay, do I have a user waiting for a response, like a synchronous API request to get some answer back straight away? Or it is more of an event-driven architecture where a lot of that time is happening in the background that no one really cares about because no one is actually actively waiting for an answer. So that's the number one thing to consider. The other thing is there's also others that allows you to artificially keep execution environment that has been created around for longer. But by default, Lambda is going to create new execution environments as the more and more requests comes in. The existing pool of workers can't handle all the workload because they're always busy. One worker can only handle one request at a time, one invocation at a time, which is great. Great thing that we can talk about the benefits of that if you're interested. But when the traffic goes away, now you've got to say more and more instance than your workload actually needs, which means that Lambda is actually going to scale down those workers and garbage collect them to free up resources for other functions and other customers potentially, so that you don't use up all the available resources. So if your function has no invocation requests at all, then it's going to scale to 0. So the next request that comes is guaranteed to be a ColdStart. So there's also methods that you can use depending on whether you're talking about, I just need to keep one instance of my function alive so that there's always going to be one function that can handle requests. Then you can use what is called a Lambda warmer. Essentially, you run a cron job that pings every single function every few minutes, because normally it takes about, 10 minutes of idle time, between 4 to 8, 10 minutes of idle time before an instance is garbage collected. So if you just ping every function at least once every 5 minutes, you're going to keep at least one instance of it running all the time. But if you need to talk about, okay, my baseline traffic is more than just one request a second, it's more than 100 requests a second, then there's also more enterprise feature that you can use nowadays called the provision concurrency. The pricing model for provision concurrency is different because now you're asking AWS to keep resources, to keep these instances running even when there are no requests going to them. So they're going to charge you an uptime cost similar to running pods or tasks on Fargate, so that you're paying an uptime cost in addition to cost based on every single request and how long it took. What's interesting, however, with a provision concurrency is that even though there's an uptime element to it in terms of the cost model, the cost per invocation and per millisecond of actual execution is cheaper. So if you have an application that has got a high utilization of those provision concurrency, it can actually work out cheaper to run, say, your baseline on provision concurrency, and then use the normal on-demand scaling for anything that's above your baseline. And with concurrency, you can also connect that to application scaling, where you can then use different metrics or do a schedule. So, for instance, if 5 o'clock is our busiest time, it's going to have a spike because we are doing food delivery. Everyone orders food around between 5 and 7. So you can use a schedule to increase the number of provision concurrency for your functions, for your user-facing APIs just before 5 o'clock. And then when the traffic is going to go away, you scale it back down after, 7, 8 o'clock, after the sort of most busy dinner time. So it is a problem, but for a lot of people that are using JavaScript or Python or Rust, so languages that has got a really good performance in terms of having a small runtime, or in the case of Rust and Go, you're compiling to native. So there is no VM you have to boot up. But if you're using Java or .NET Core, then you have to think about how best to handle that. In the last 12 to 18 months, AWS has done a lot of work to improve the support for Java and .NET specifically for improving ColdStart by supporting ahead of time compilation. So for Java, a popular option will be to use a Grail VM. Is it Grail VM? Yeah, to compile your code essentially to native code, so that you don't have this big initialization time for the class loader and the Java VM. And same with .NET Core. .NET Core has got the .NET Native support, which they have added support for in the last trend. I think now you can use that with .NET 6 and .NET 7. So you can then use ahead of time compilation to compile your .NET application to native code. So again, you've got really good ColdStart performance. So if you're able to, I guess the other thing I would say is that if you can optimize your code so that the ColdStart performance is still within your, say, P99 SLA, then you're fine. Don't just worry about the fact that some requests will be slower. Some requests has always been slower, even when it's on server. I remember stop the world garbage collections happening on my .NET and Java applications. You always see some spikes around that shows up around your P99. And remember, I think 12 years ago, 15 years ago, Stack Overflow, they did this massive piece of work because in .NET you have value types as well as the reference types. And the value types are allocated to the stack so that you can reduce the amount of pressure on the garbage collector. So in order to minimize this, stop the world garbage collections and reduce some of these P99 latencies, so they rewrote the entire application to use as much value type as possible. So these kind of problems has always existed. They're maybe less systematic compared to when you've got something that's scaled to zero and have to worry about creating the fresh environments on demand as Lambda. But if you're able to optimize your code so that even when cold starts happen, it's still okay for as far as your P99 is concerned, then don't do anything. Just be glad and be happy.
That makes sense. Totally. And the next thing that once we have architected the application, once we have built the application and deployed it, the next thing we want to do is to monitor, right? So in the traditional way of doing things is that we also monitor a lot of server level metrics, right? The CPU usage, the memory usage, the disk usage and all that. With serverless, how does that change? How can I monitor my application? Is it more like now I'm monitoring only the business metrics and not the infrastructure level metrics, or there is more to it? How does that change?
So monitoring is a small part of what we consider observability. And observability is, I guess maybe we'll actually define it. So there's different people who define observability differently. My favorite definition is observability is a measure of how well you're able to measure the internal state or understand the internal state of your system just by looking at its external outputs. So metrics is one form of external output that you should look at. And absolutely, for one, you don't have access to the underlying EC2 metrics. You can't measure the disk or networking or whatever for your Lambda functions. Yeah. But what you can measure are the number of invocations, the duration, error count. So higher level metrics that you can use to understand what is happening with your function at the macro level. And it's also important to distinguish between what's happening at the macro level, as in at a high level, is this function behaving slowly, or is it throwing a lot of errors, or is my application throwing a lot of errors? But also, oftentimes, you need to be able to go down to the micro level. So understand what happened on individual transactions. So a customer tells you that, hey, I tried to buy some stocks from your application. I got this error, give you a screenshot of the error message. How well can you then easily go from that to figure out, okay, this is a transaction and it errored because there was some bug in our code, or maybe there was an error from the service that we're using, like Shopify. And how can I go from the screenshot the customer is showing me to figuring out, finding the right log messages and the traces and whatnot. So a lot of the tools that you might be familiar with by using AWS, you can use them still. Things like CloudWatch, as in logs, metrics, alerts, but also X-Ray and whatever other things that you want to use. I think for serverless, a lot of the monitoring stuff is actually a lot easier once you find the right tool. And my favorite tool is called Lumigo. You can go to lumigo.io to try it out. They got a free tier. So what it does is it allows me to easily enable active tracing on my function so that I can see in the Lumigo console straight away, okay, go to the dashboard and see which of my functions has got the most errors, most cold starts, the longest duration. I can see, okay, all the different dependencies that my function depends on. I can see, okay, for some reason, this one service, the P95 percentile latency is very high. I can click on that and see the transactions where we made a request to that service or that endpoint to see, okay, so now whenever we try to make a post request to get this particular ID or for product or whatever, it tends to take a long time to return. But also importantly, I'm able to then quickly drill into a transaction to see, okay, I've got this transaction involving multiple Lambda functions. Here's the API call going to a Lambda function, which wrote something to the DynamoDB. And the DynamoDB is connected to a stream, which triggers another Lambda function that does something to call DynamoDB to read some data, and then you push an event to event bridge, trigger another function, which does something else, put something to S3, triggers event, and the Lambda function. Then, so you see, with a lot of serverless architectures, they're also event-driven architectures. So it's not just about, okay, one function handles the API request and calls database. Oftentimes, there's a whole sort of like this stream of other functions that are connected to this initial request. And the Lumigo allows you to visualize all of that without having to change your business logic. You can just enable tracing on your functions, and you can get a lot of that out of the box. And you can see the transaction in terms of that visual diagram of everything that was involved in the transaction, but the logs for all the Lambda function invocations that was involved in the transaction as well, so that I can then see them side by side. If you used X-Ray before, you've probably seen those waterfall graph where you can see, okay, for this, the end-to-end latency for this entire workflow, this is the transaction. And then for each function, how long it took to run, to call DynamoDB, to, push an event to event bridge. So you see that within Lumigo as well. And it also integrates with like Slack, and it's got the built-in alerting. When I've got errors in my functions, or my function times out or runs out of memory, or a number of other errors, it just pings me on Slack, PagerDuty. So I actually find that the right tool, in this case, using Lumigo, I can actually get a lot of visibility. So I've been able to support entire applications on my own that would have taken maybe a whole team to support in the past.
Yeah, sounds perfect. If I'm able to observe what's happening inside my application, as you mentioned, like understanding the internal state just by looking at the output, right?
Yeah.
That's an interesting way to define observability. What are the use cases where you think serverless does not make a lot of sense? Are there some practical use cases where people have contacted you and you said, no, please don't use serverless?
Yeah, there's a couple of, I would say, it's important to look at your non-functional requirements. I think oftentimes that's where you make the decision to say, let's move these to containers instead. Because the number one reason to not use Lambda, not serverless, just not Lambda, because you can see use DynamoDB, S3, and all of that other serverless services. But specifically for Lambda, there are a few other things that you got to worry about. Like for Lambda, you've got a number of limits in terms of the execution time is a big one. So you can only run invocation can only run for 15 minutes. So if there's no way for you to break up, say, a long running ETL job so that you can do them in small chunks or do them in parallel, then, okay, maybe just put that into Fargate. So have something trigger a Fargate task. And I've seen a lot of people do this where they have an event triggers a Lambda function that starts a Fargate task because unlike Google Cloud Run, there's no event trigger for Fargate just yet. At least I don't think so, unless something changed recently. So a lot of people actually use Lambda to trigger Fargate. There's just a few services that can start a Fargate task, step functions. I think maybe EventBridge nowadays as well. But if you can't use that, and then you can always use a Lambda function to, say, pick up a message from SQS and then start a Fargate task to do your long-running job. So in that case, the fact that you've got a 15 minutes execution time limit, I think is a good thing. And I don't want them to actually extend that further. It used to be 5 minutes, but I think anything that can be done most things can be done within 15 minutes. And I think it's good that people have a cutoff point where they think maybe something else is easier. So that Fargate, so that 15 minutes execution time for Lambda, I think is good enough for 99.9% of people or workloads. If things that are not good for it's not coming done in 15 minutes, it probably shouldn't be using Lambda functions. So just moving into Fargate the task, I think that's a good reason. Another reason could be, okay, I've got this really high throughput API, and with API Gateway and the Lambda, you're paying for individual requests, which is great up to a certain point. But then if you've got an API that's doing, say, I don't know, a few thousand requests per second consistently, then that can get quite expensive. So you're looking at the cost for that API and Lambda function, but you always have to think about the total cost of ownership for a solution. That includes the people you need to hire to look after the solution, and the people that you have to hire to look after your, I don't know, Kubernetes cluster or whatever, are probably going to cost a lot more than paying AWS for Lambda functions and API Gateway, up to a certain point where I've got maybe a fairly simple API, I've got a few endpoints, but they're doing massive volume. And so a good example would be the Finland's national television. They've got this service that collects user impressions from the app when they're watching a TV program. They say, oh, we like it, we don't like it, answer questions and stuff like that. It's a very simple API, not many endpoints, but the volume they're getting is very high throughput. It's something in the order of several billion requests a day or something like that. So fairly high volume. And you think, okay, if the API is running on API Gateway and Lambda, then you can get quite expensive. And it'll be cheaper at that point to say, let's just hire someone to look after containerized environment that can do this with maybe a dozen of containers. So even though we're paying someone which is going to be a lot more expensive than using API Gateway and Lambda, but then at a certain scale, it becomes the total cost of ownership is still going to shift towards using containers.
Yeah.
So that's another good example for where the non-functional requirement would say, okay, this can be done with serverless, but it's just more cost efficient to go containers. Another one could be performance. With Lambda, we talked about ColdStarts, and for most applications, a bit of a occasional slow response time is okay. But what happens if you're trying to build something that requires ultra low latency at a really high sort of percentage level, as in percentile? So example could be one of my last full-time jobs. I was working for a game studio. We were building an online mobile game, which is a multiplayer online battle arena. So think Fortnite, that kind of thing, where 10 people playing in an arena, they try to shoot each other, that kind of thing, right? So it's on mobile, it's live, it's people are doing things constantly. So there's a really strict latency requirement. I think our target was something like sub 20 millisecond at the 99.99 percentile. And at that point, it's just really hard to guarantee that level of performance on Lambda. And we also had to implement, a custom binary-based application protocol running on top of UDP, custom UDP stacks. A lot of the common things that you get from web development also just didn't work because we had to build something that is much more reliable in a poor networking environment where the packet drop rate is high. So there's a lot of custom networking stack, which again requires us to do a lot of tuning on the networking layer on the OS, which again, we don't have those low-level assets when we run our code on Lambda. So yeah, that's another interesting use, I guess, a non-functional requirement that would say, okay, Lambda is just going to make things harder. So let's not use Lambda. But in terms of actual use cases, I think you can pretty much build everything using just serverless technologies nowadays. But those are some of the things that I would say, look at the limits, look at the non-functional requirements, including cost efficiency, and see whether or not the serverless is no-go. But I guess the popular approach people take would be to go serverless first, but not serverless only. So you start thinking, can I build this with serverless? But if I can't, because of any reason, let's move it to containers.
That makes sense. And I think like some of these might be like limitations of serverless at this point. So do you think these will be fixed? It will be improved in the future? And with this, I also wanted to ask you, what is the future of serverless? Is it pretty
Sure.
much feature complete, or there's a lot to happen yet in this space?
I think we're just getting started. And also, I think the future, when we say the limitation of serverless, really we're talking about limitations of function as a service.
Yeah.
And to some extent, I don't think it will ever be feature complete. And also at the same time, I think the future is going to be more of a sort of a convergence of container technologies. Fargate is, we may call serverless container technology because it's got a lot of similar characteristics in terms of, okay, my Fargate task is allocated to ECS, but no, I can say I don't want to manage the ECS cluster. I can just say use the pool of instances that the Fargate team manages and allocate there, and so I don't have to worry about the underlying security for the cluster. So you can call Fargate serverless containers, and with things like Cloud Run, you also now have the sort of event-driven programming model bringing to containers. Whereas with Lambda, you've got Lambda has got some sort of container-like or serverfold features like provision concurrency. You can even package your Lambda function using container images. It's not going to run a container per se, but you can package your application using a Docker image file, which can be useful if you have, say, people do that most often when they have like a machine learning model that's really big, like I think the machine images can sometimes be like, I think up to 10 gig, there's a limit. Whereas for normal Lambda function that you upload to S3 and you load it as a zip file, the limit is 256 meg. So Lambda is introducing more sort of container-like features, whereas container services are introducing more as a service-like features. There's also full-on frameworks that lets you run function as a service on top of Kubernetes, like Knative and a whole other bunch of different things, and OpenFast and quite a lot of these different solutions that try to give you Lambda-like programming model on top of your containerized environment. So I think the two technologies or two forms of technology factors would continue to merge and become more and more like each other. And I don't know, I guess in terms of future-wise, if at some point we stop talking about serverless, I think that would mean that we've succeeded, in the same way that no one really talks about NoSQL anymore. They talk about specific technologies and talk about specific characteristics, even though back in the day, we needed a separate term to identify database technologies that are not relational.
Yeah.
Nowadays, no one really talks about NoSQL anymore, which I guess by and large means we've made it for databases. And therefore, in terms of serverless, if at some point we can safely say no one uses serverless anymore, then we've probably made it. We've become ubiquitous, and everything is maybe got some serverless elements already.
Yeah, absolutely. Looking forward to it. This discussion has been really insightful. I've learned a lot, and especially on different perspective that you have shared, mainly on how to think about vendor lock-in, how to think about multi-cloud, how to first focus on the problem at hand and then aren't on it. And it's definitely been an interesting discussion. And thanks a lot for joining us today on the show. And
Thanks for having me.
with this, I just want to ask you one last question. As a developer, if I want to learn about serverless, what would you recommend?
I recommend that you start just building something, and there's no substitute for just trying to build something yourself. I do have a few courses and a few workshops that can probably help you get started, so that you have at least some guidance, a structure in terms of this is how you build an application from start to end, including how to do testing, how to do deployment, and how to do observability. In fact, I've got a 2-day workshop that's starting tomorrow. If you want to look at other future workshops I'm going to run, go to productionreadyserverless.com and check it out. Also got a few other courses and books. You can go to theburningmonk.com, where I've been writing a lot about serverless over the last God knows how many years. Got over 150, maybe 200 articles. You can read about lots of different things around the serverless. Yeah, go from there. And yeah, if you need to reach out to me, happy to. You can find me as the Burning Monk on Twitter and LinkedIn and lots of other places.
Yeah, absolutely. I'll make sure I add all the important links that you mentioned in the video description. And I hope our viewers will like this episode. And if you did, please share and subscribe to the channel, because it motivates me to create more such episodes.